Chapter 11. Web3 Unboxed. Principles shaping the future of the Internet. What is Web3? Web3, also known as the decentralized web, refers to a vision of the Internet that is more decentralized, secure, private, and user-centric compared to the current web architecture, Web 2.0. It envisions a future where users have more control over their data, identities, and interactions online, while reducing reliance on central authorities and intermediaries. Blockchain technology plays a significant role in the realization of Web3 by providing a decentralized and tamper-proof ledger for recording transactions and data. The ethos of Web3. Web3 encompasses technologies like blockchain, which shift control of data ownership and management away from centralized entities, marking a departure from the predominant model of Internet governance. Unlike traditional Internet applications, which are typically controlled by centralized entities, Web3 technologies facilitate community-driven projects where end users have greater control over their data and contributions. These technologies incorporate mechanisms for decentralized data management and interaction regulation, eliminating the need for central authorities to oversee these processes. Distinguishing Web3 from Web 3.0. When discussing Web3 and Web 3.0, it's important to recognize their subtle yet distinct differences. Web3 often denotes an earlier conceptual stage, whereas Web 3.0 embodies the more evolved iteration. Web3 lays the groundwork for what's to come, reflecting a transitional phase towards a more decentralized Internet landscape. On the other hand, Web 3.0 encapsulates the full realization of this vision, characterized by decentralized architectures, enhanced interoperability, and user empowerment. While the terms are sometimes used interchangeably, this distinction offers clarity in understanding the evolution of the Internet. In the context of blockchain, identity, AI, and the metaverse, Web 3.0 emerges as a convergence of these technologies, reshaping the digital landscape. Blockchain technology serves as the backbone, facilitating trustless transactions and decentralized applications. Decentralized identity solutions empower individuals with greater control over their digital personas, fostering a more secure and transparent online environment. Artificial intelligence augments user experiences, enabling personalized services and smarter decision-making processes. Meanwhile, the metaverse represents the culmination of immersive virtual experiences, where blockchain ensures ownership rights and interoperability across virtual worlds. Together, these elements redefine the Internet, ushering in a new era of decentralization, autonomy, and interconnectedness. Decentralization. The core tenets of Web 3.0 can be summarized into four key features. Firstly, decentralization lies at the heart of Web 3.0. With a focus on distributing and storing data across decentralized networks. In these networks, ownership of infrastructure is diversified, and users have the autonomy to determine where their data resides, rather than relying on centralized entities for storage and management. Trustlessness. Trustlessness is another fundamental aspect of Web 3.0, addressing the inherent vulnerabilities associated with centralized systems where users must place trust in a central authority to safeguard their data and transactions. By eliminating the need for trust in any single party, Web 3.0 enables secure transactions and interactions without relying on centralized intermediaries. Semantic web. Semantic web technologies underpin the third core idea of Web 3.0. Enhancing the capabilities of applications to understand and process web data based on its content and context. This involves leveraging metadata and artificial intelligence to derive meaning from user-generated data, enabling more accurate and contextually relevant services such as search engines and intelligent agents. Interoperability. Interoperability serves as the final pillar of Web 3.0. Aiming to foster seamless data exchange between diverse platforms and technologies, without the need for intermediaries. By making data portable and enabling users to maintain their preferences across various services, interoperability enhances the flexibility and usability of web applications. In practice, Web 3.0 technologies have far-reaching implications across various domains. From enabling borderless transactions through cryptocurrency technologies to expanding the reach of the web to encompass a wider array of Internet of Things, IoT, devices. By decentralizing control, enhancing security, improving data processing capabilities, and promoting interoperability, Web 3.0 represents a paradigm shift towards a more open, transparent and user-centric Internet ecosystem. The importance of Web 3 community. The importance of the Web 3 community lies in its pivotal role in shaping the future of the Internet. As the driving force behind the development, adoption, and evolution of decentralized technologies, the Web 3 community plays a crucial role in realizing the vision of a more open, decentralized, and user-centric web. One key aspect of the Web 3 community is its dedication to the principles of decentralization, transparency, and user empowerment. Unlike traditional Internet models where power and control are concentrated in the hands of a few centralized entities, the Web 3.0 community advocates for distributed architectures that prioritize user ownership of data and enable peer-to-peer interactions without the need for intermediaries. By championing these principles, the Web 3.0 community seeks to create a more equitable and inclusive digital ecosystem where individuals have greater control over their online identities, transactions, and interactions. The Web 3 community supports innovation and collaboration among developers, entrepreneurs, researchers, and enthusiasts from diverse backgrounds. Through open-source development, hackathons, conferences, and online forums, community members collaborate to build and improve decentralized protocols, applications, and tools. This collaborative ethos promotes knowledge sharing, accelerates technological advancements, and drives the adoption of Web 3 technologies across various industries and sectors. Moreover, the Web 3 community serves as a catalyst for social and economic empowerment, particularly in underserved and marginalized communities. By leveraging decentralized technologies, community-led initiatives aim to address issues such as financial inclusion, censorship resistance, and data sovereignty, empowering individuals to participate more actively in the digital economy and exercise greater control over their online experiences. Main technology of Web 3.0. Tokenization. Another crucial technology driving the advancement of Web 3.0 is tokenization. Tokenization involves representing real-world or digital assets as digital tokens on a blockchain. These tokens serve as cryptographic representations of ownership, access rights, or other forms of value. For example, assets like real estate, stocks, commodities, art, music, and even in-game items can be tokenized. Each token can represent a specific fraction or whole unit of the underlying asset, enabling divisibility and facilitating easy trading. There are various types of tokens, including security tokens subject to securities regulations and non-fungible tokens, NFTs, representing unique, indivisible assets. WebAssembly. Additionally, WebAssembly, WASM, plays a crucial role in Web 3.0 development. WASM is a binary instruction format for a stack-based virtual machine that operates within a sandboxed environment within web browsers. This means that it cannot access the user's local file system, ensuring security. WASM enables high-performance code execution within web browsers, offering developers the ability to run code at near-native speed. This capability provides a solid foundation for decentralized applications to operate efficiently across different platforms, offering a significant performance boost compared to traditional web technologies like JavaScript. Overall, blockchain technology, tokenization, WebAssembly, and semantic web technologies are among the main technologies driving the development of Web 3. These technologies provide the foundation for decentralized, transparent, and user-centric Internet applications. By leveraging these technologies, Web 3 aims to address the limitations of previous Internet paradigms and usher in a new era of innovation, collaboration, and empowerment on the web. Example of Web3 applications. Smart contracts. Among the example Web3 applications, smart contracts stand out as a revolutionary innovation. These contracts, coded with predefined rules, automatically execute when specific conditions are met. For instance, in a transaction where ownership of an item transfers upon payment, sending the asking price to the contract triggers an automatic update of the ledger, reflecting the new owner. Decentralized autonomous organizations, DAOs, exemplify smart contracts in action, facilitating decentralized decision-making over pooled resources through token holder voting. Decentralized identification. Another significant application of blockchain technology is in decentralized identification systems. Traditional online systems often rely on centralized identity providers for managing user identities. Decentralized identity solutions aim to empower individuals by granting them more control over their digital identities. By utilizing globally unique identifiers associated with decentralized identifiers, DIDs, users can selectively disclose identity attributes while minimizing exposure to personally identifiable information, PII, thus enhancing privacy and security in identity verification processes. Interplanetary File System, IPFS. Interplanetary File System, IPFS, serves as another cornerstone of Web3 applications. IPFS offers a decentralized and distributed file storage system, providing a more efficient and resilient method for storing and accessing content. Each file on IPFS is assigned a unique cryptographic hash, enabling efficient retrieval and distribution of content across the network. With IPFS, content is stored and distributed across a peer-to-peer network, eliminating the reliance on centralized servers and ensuring redundancy and fault tolerance. Decentralized finance. Furthermore, decentralized finance, DeFi, represents an expanding field within Web3. Leveraging blockchain technology to create financial instruments and services without intermediaries. Smart contracts enable programmable conditions for financial transactions, such as mortgages, bonds, and securities. By eliminating intermediaries, DeFi aims to increase efficiency, reduce costs, and democratize access to financial services. Decentralized applications. Web3 also encompasses decentralized applications, DApps, which operate on blockchain networks and utilize smart contracts for their functionality. These DApps span various industries, including finance, gaming, supply chain management, and social networking, among others. By leveraging blockchain technology, DApps offer increased transparency, security, and user control compared to their centralized counterparts. In essence, Web3 represents a shift towards a more decentralized internet ecosystem, enabled by technologies like blockchain, tokenization, and decentralized identity. This example emphasizes user control, transparency, and autonomy, offering the potential for a more equitable distribution of wealth and information. Embracing Web3 entails more than just adopting new technologies, it requires a fundamental shift in mindset towards empowerment, autonomy, and self-determination. One aspect of Web3 worth exploring is its potential to redefine the relationship between individuals and their data. By embracing decentralized identity solutions and prioritizing data ownership and control, individuals can reclaim sovereignty over their digital identities and personal information. This conversion towards user centricity cultivates a sense of empowerment and agency in an increasingly digitized world. Web3 challenges. Web3, the next evolutionary step in the Internet's development, has undergone significant changes in its onboarding process, closely resembling Web2's familiar profile structure. This evolution aims to enhance user experience and accessibility, marking a positive trend in the advancement of the digital landscape. However, despite these strides, Web3 still grapples with challenges, particularly in the realm of user interface and experience. The persistence of clunky interfaces and regulatory uncertainties serves as obstacles to achieving mainstream adoption. Moreover, the complexity of technical knowledge and decision-making further compounds these barriers. posing significant challenges to widespread acceptance. Education. Education plays a pivotal role in overcoming these hurdles. Educating users about blockchain principles and emphasizing self-custody are essential strategies for empowering individuals and driving Web3 adoption forward. It is imperative that Web3 interfaces prioritize simplicity and aesthetics to accommodate both technically experienced users and newcomers effectively. Companies within the Web3 sphere are actively working towards improving user experience, recognizing it as a critical aspect of fostering growth and acceptance within the digital ecosystem. One significant avenue for expanding the Web3 user base lies in organized decentralized initiatives. These initiatives focus on elucidating key blockchain principles, promoting best security practices, and highlighting the benefits of decentralized systems. Despite the progress made, there remains a widespread lack of understanding among the general populace regarding blockchain technology and its potential advantages. Negative misconceptions about the industry persist, further exacerbating the challenge of gaining public trust and support. Additionally, the failure to widely broadcast enterprise use cases and real-world value contributes to the difficulty individuals face in discerning the tangible benefits offered by Web3 applications. Improving general awareness of the technology is crucial for driving adoption forward. As more users are onboarded, a larger pool of feedback becomes available, enabling projects to iterate and refine their offerings to better suit user needs. This iterative process ultimately leads to advancements in Web3 accessibility, facilitating a smoother transition for new users entering the digital space. The Web3 industry has witnessed waves of innovation, ranging from self-custodial wallets to hardware wallets, all contributing to the diversification and enrichment of the digital landscape. Onboarding. Despite the progress made in simplifying the user onboarding process, challenges persist within the Web3 industry. Bridging the knowledge gap through education and simplifying design are identified as critical steps towards achieving mainstream adoption. Industry experts acknowledge the importance of these efforts in making Web3 more accessible and user-friendly, thereby paving the way for broader acceptance and integration into everyday life. As the digital landscape continues to evolve, addressing these challenges will remain a priority, ensuring that Web3 realizes its full potential as a transformative force in the realm of technology and beyond. Web3 and artificial intelligence. Web3 and artificial intelligence, AI, can collaborate in numerous ways, synergizing their strengths to innovate applications and services. By hosting decentralized marketplaces, Web3 platforms facilitate the trading, sharing, and deployment of AI models and algorithms. Smart contracts ensure transparent and trustworthy transactions, democratizing access to AI capabilities and advancing collaboration among developers and researchers. Furthermore, Web3's secure and decentralized data sharing capabilities enable individuals to retain ownership and control over their data while still benefiting from collective insights. AI algorithms can be trained on distributed datasets without centralizing sensitive information, thus preserving privacy. This approach allows for the development of privacy-preserving AI solutions that extract valuable insights from decentralized data sources. Additionally, AI can enhance content curation in Web3 environments by analyzing decentralized content sources and providing personalized and relevant content recommendations to users. By understanding user preferences and behaviors without compromising privacy, AI improves information discovery and consumption across decentralized platforms. Furthermore, in decentralized autonomous organizations, DAOs, AI-driven autonomous agents can automate decision-making processes and task execution, optimizing resource allocation and streamlining governance mechanisms. These agents enhance the efficiency of decentralized collective decision-making and contribute to the autonomy of DAOs. Moreover, AI techniques such as machine learning and natural language processing can analyze blockchain data for various purposes within the Web3 ecosystem. By applying AI for tasks such as fraud detection, pattern recognition, and sentiment analysis, insights gained can improve the security, efficiency, and user experience of blockchain-based applications. Integrating AI capabilities into smart contracts enables more dynamic and adaptive decentralized applications. AI algorithms can analyze real-time data inputs and autonomously adjust contract parameters or trigger actions based on predefined conditions, enhancing the flexibility and responsiveness of decentralized systems.